Hey everybody. So this video is going to be focusing on motor neurons and motor units. And before we begin this, I just want to emphasize that you are going to hear some repetition throughout these videos. And that is because I believe that it's really important that we are bringing up topics over and over again so that you can better understand what we're doing and how it applies throughout the chapters. And that said, you're probably looking at the title of this thinking to yourself, motor neurons. That's not muscles. So why are we looking at neurons? And that is because, as you're going to see as a theme throughout the different chapters in anatomy and physiology, all of these chapters are going to come together in one way, shape, or form. And that's why we're going to talk a little bit about how neurons work, because without the neurons, we are not going to be able to receive information and the signal for the muscles to contract. So, that said, motor neurons. A motor neuron is exactly what it sounds like. Motor. Something's going on. There's movement. So these are going to be the skeletal. These are going to be the neurons found within the skeletal muscle that is going to activate the muscle and tell it to contract, and that's going to be very important. Not only that, but each muscle fiber is supplied with only one motor nerve fiber. So each muscle is only going to have one neuron associated with it telling it what to do. It's not going to have multiple neurons, just one. And before we move into a motor unit, just keep this in mind here at the top. Same is a great way to better understand which neurons we're talking about. So sensory are going to be afferent neurons. Motor units are going to be efferent. So sensory are afferent, motor are efferent. What the heck does that mean? If you forgot, here's a nice little representation showing what's going on. We have skin, we have a nerve running to the spinal cord, and then we have the spinal cord running to the muscles. So there are two different paths that the nerves can travel. You can travel towards the central nervous system, spinal cord, which eventually can go to the brain or stay here, which we'll talk about later. Or it can go from the central nervous system to a destination. In this case, it would be a muscle. So afferent is going towards the central nervous system. Efferent is going to the effector, the affected area. So afferent is away to the central nervous system. Efferent is exiting the central nervous system, E, to the effecting area, in this case, the muscle. So that said, same sensory information is always going to go from the initial location towards the central nervous system, and then the actual motor output is going to come from the central nervous system and to the affected area. And if you think about it, you don't really have to memorize what's going on there. Just think about what makes sense. If you are receiving a stimulus of any kind, it is going to go to the central nervous system so that it can interpret what's going on. Is this a bee flying into my face? Is this my dog about to lick my face? Right? You have to be able to interpret that information. Is my hand on a hot stove? You can't answer any of those questions without a signal to the central nervous system. From there, your body will interpret what's going on, it'll make a decision, and it'll send the signal to the affecting area. Right? So if I have my hand on a hot stove, the heat is going to come in to the central nervous system. In this case, it'll go to the spinal cord and then just right back out because it's a reflex, and it's going to tell your muscles to move. So that's the idea there. Anyways, back to this motor unit. A motor unit is the one nerve fiber we just talked about, because again, each muscle is going to have only one nerve fiber, and all of the muscle fibers that it's going to innervate, meaning that one nerve can branch out and impact multiple muscle cells. Here's an example of what that looks like. In this case here, motor neuron 1, the lighter color, it comes in and it branches off and touches 1, 2, 3 different muscle fibers. Whereas motor unit 2 is going to come in and innervate 1, 2 muscle fibers. It all depends on the type of muscle and where in the body we're talking about. So, as mentioned here, there are two examples. If you're talking about gross motor movement, like big picture things, like if you're going to walk, right? If you're going to use your legs, the huge muscles in your thighs, right? In that case, you're going to have one neuron innervating many, many, many muscle fibers because they're all going to do the same thing at once, right? If you think about your leg, you're not going to have, it's just one movement, right? If I'm going to do a squat, it's just my legs pushing up, right? However, if I'm going to do something with more fine motor control, that's something like your eye, whereas one neuron is going to innervate only a couple of nerve fibers. So in this case here, it says the eye is only going to innervate about 23 muscle fibers at a time. Why? Because it allows for much finer control, more neurons in the area, and therefore you can do more things. So if you think about your eyes, you can look all over the place. You're not just looking left, right, up, down, right? You're able to use those muscles to move your eyes in the directions that you want with very fine motor control. So that said, motor neurons used to send the motor output to the muscles to tell it what to do, to tell it when to contract, how hard they should contract, so on and so forth. And then the motor unit is the individual neuron and all of the muscle fibers that they are interacting with. If you have any questions on this, please let me know.